What's up, guys? Welcome in to the live. Welcome to my live, guys. We'll let the room warm up a little bit. We're gonna talk about slopes, theory of lines a little bit. It's been a while since I've been on here. So, we're gonna go some problems. Let the room warm up a little bit, guys. Welcome in, welcome in. So I'm gonna put a problem on the board. Hope somebody come in. So yesterday I covered theory of lines. So we'll put some theorems up here. Alright, so we're gonna be looking at M1, M2. Okay, it's one of them. And two. White intercept form. Okay. M1, M2, and 3. So it's reciprocal with dealing with that. So yeah, as you come in, guys, we're gonna be proving those properties in a minute. So welcome to my live. So I'm gonna scoot it back just a little bit. Welcome in, guys. Welcome to my live. We're talking about proving some lines here. Properties deals with the lines. Let's go ahead, guys. Go ahead and subscribe to me. Go ahead and like the live. Engage in the comments. Like the live. Engage in the comments. Let's go. So we're gonna do together. We're gonna do straight proofs of these lines. I'm gonna try to write this nice and neat, and we guys look this up on the playback. Okay, what's going on here? All right, guys. So first thing we're gonna do, we're gonna prove some propositions about lines. So So this is going to be a derivation. So we're going to allow d equals x minus x sum naught d2 y minus y sub naught. So with these distances, we'll put it on top. Actually, D2, D1. So we go ahead, cross that out. And this becomes which eventually give us del y, del x. All right? Not only distances, but this is the change, which denotes this. Okay? So we can therefore conclude your slope will be m equals del y over del x. And also will be slope y over x. X cannot be 0. Let's go ahead and subscribe to me, please. Go ahead and engage in the comments. Please engage in the comments. So that's the first part of our proof. So the second part of our proof, we're going to allow y1, y sub naught hold on, guys. Today's just might not be my day. Let's try it again. Okay, we'll do y. Call it regular y. X sub naught, that is good, right? And then we're going to let this equal y1 minus y2. y1 minus y2. You can multiply both sides by the denominator. And times x sub naught. Then we have y sub naught equals m, x sub naught. It's called a point-intercept slope form of the equation. Okay, everything looks good. Welcome in, welcome in. All right, so we did 2 proofs already. Now I'm going to do a more extensive proof. All right, parallelism. So we'll put it, call this parallelism. So let's say you have 2 perpendicular lines. So call this A, B, C, A prime, B prime, C prime. All right? So we want to use CB. So C B over AB. M2 going to equals C prime B prime A prime B prime. And since M1 equals M2, so we say C B over AB is equal to C prime B prime over A prime B prime. And since the two are equal, then we say thus L1 is parallel to L2, period. L1, L2. So the slopes are equal, then so does the slopes. If the slopes are equal, we know that the thing is, or the lines are parallel. If they're equal, they are parallel. And that's so important, guys. Go ahead, subscribe to me, guys. Go ahead, like the lives. Go ahead, keep subscribing to me. This is very important, guys. Let's show that the opposite. So we show the opposite. So be very careful, guys. Very careful. L1 and L2. So from here, we're going to do the slopes. If you look at it, one is the inverse of the other. So now I'm just going to prove that proposition. So I'm going to prove M1, M2 equals to -1. I'm just going to prove that. So if this increasing, and then this is decreasing. So for the L1 case, we'll say M1 equals A over B. For the L2 case, we'll say M2 is equal to B over A with the negative attached to it. Let me redraw that. That was kind of messy. Let me redraw that. I want to be real explicit here. So M1 is equal to A over B. M2 equals the negative B over A. Okay? So now we'll go straight ahead. So M1 times 1 over M2, which implies the fact A over B times 1, the negative 1 over A over B, which implies the fact A over B times the negative B over A. B over A, which implies the fact the negative of the whole thing, so we got A over A. We got B over B, which equals negative 1 times 1, which equals negative 1. And therefore, M1 over M2 is equal to negative 1. Very important, guys. Very important. Very important. Go ahead, like the live, guys. Go ahead, tap that screen for me, please. It's 17. Yep. We'll keep it under 30 minutes. Sorry about that, guys. Welcome in, guys. This is a proof of. If you guys are taking algebra pre-calculus, this is a great class, guys. You just everything just simple for the for this course. It's algebra, guys. Algebra. So let's do a lot of proofs. All right, let's do lots of proofs. So that was pretty fun, guys. That was pretty fun. And last but not least, the idea of perpendicularity. So you have L1, L2. That means that each set of these points have that in common. So what do we know about perpendicular lines? Okay? This is on the 0. This is on the 0 as well. So you have x equals 0 and you have y equals 0. What does that tell us about these lines? X equals 0, y equals 0, right? Or for any case, so you have x equals, so you're going to have x equals a, and you have y equals b. Okay, so we'll just shift this out, right? We're going to shift this out in space. So it'll be x equals a, and y equals b. So you have an intersection at that right there. So you have A and B. Call this P. So you just have an intersection. So if this, so we say 0, 0 implies the fact A and B. So if you just have that, so you have origin, then this also gives you A comma B. So you just merely have an intersection no matter where on the graph. So we can conclude AB implies A prime, B prime. So guess what? A minus A prime equals 0. B minus B prime equals 0. That's what it's telling us. So from the origin, okay, let's look from the origin. Call it A comma B, and call this 0, 0. Again, we have, so now we're going to get their distances. So we say D equals 0A, actually 0B, A0, right? Their distances, which implies B minus 0, A minus 0, which equals A, B, A squared, B squared, only for positive distance, right? Only for positive distance. Call it A for A more than 0. Call it B for B more than 0. Okay, that's what we want to show. Welcome in, welcome in. Thank you guys. Welcome in, welcome in. Guys, we're going to lay off the politics. All right, guys, now I think that's it. So this is it for that part. So we covered a lot of stuff about lines, a lot of stuff. So the reason why I'm doing this, guys, is just to recap what I tutored on my last line. So you guys gotta catch me on my next post. We got 5 more minutes. I think we got enough for one more proof. The point slope intercept form. We got to show that. All right, so let's go ahead and derive that equation. So we got enough tools to do that. So let's say m is equal to y over x. It's by theorem 1. And we have intercept 0b. All right. So now we have to derive this. So we got y. So y minus y sub naught equals m x minus x sub naught. So y equal y minus. So y minus b equals the slope of x minus 0. Okay, so we got y minus b equals m times x. So y equals m times x plus b as desired. Y equals mx plus b. By the point slope intercept form, right? Point slope intercept form. And I will get a little deeper than that. But that's, if you know the point slope intercept form, just put in b for y, 0 for x sub naught, then they solve the equation. That's simple. Let's keep locking it live, guys. Keep locking it live. Keep subscribing. Go ahead and subscribe. So we're doing all the proofs of the linear equations. So next week we're gonna start some more stuff dealing with functions. So there's a lot of stuff coming up. So guys, thank you for joining me. Appreciate that. You know, a lot of proof in half an hour, guys. It's very, very awesome. So keep coming in, keep tuning in. It's the school year. Look at my videos. You wonder where all this stuff comes from. So let's do a summary. Let's do a summary. So we talked about. So we talked about y-intercept form. And number 3. It's called the slope for M1, M2, M1, M2 equals -1. Talk about that. And we also did something about parallel, right? 5. M1 equals M2 implies the fact L1 is parallel to L2. Very important stuff, guys. Very important. I want you guys to memorize that. So thank you guys for tuning in. We hope you have a wonderful day. All right. So we hope you have a wonderful day, guys. You guys did great. So anybody have any questions about this theorem? Anybody have any questions? Let's keep liking the live, guys. Let's keep subscribing. So nobody have no questions? So nobody have no questions? I got the cameras in my hand, guys. All right, guys, we're going to catch y'all later. It's been a pleasure, and we'll see y'all later. Thank you for watching. We are out. Bye-bye.